I hope you are doing well and your preparation for the final exam is going pretty good. I decided to record a lecture and upload on Moodle because most of you missed the very last lecture. Only one person was present in the class, and the material I covered in the very last lecture is important, and there's going to be something on the final exam from that material. So I am going to record this lecture and I will upload this on Moodle, and hopefully you get the chance to watch this. Uh, I have never recorded any lecture before, so this is my first time trying. So if it's not perfect, so I apologize in advance. Okay. So the two things we covered in the very last lecture. One was let me. Okay, so first thing was called Pascal's principle. And the second topic we covered was, I believe it's pronounced Archimedes' principle. And it's also called buoyant force law, or simply buoyant force principle. Okay, so I'm gonna go over both of these concepts in this video, and so let's first go with the Pascal's principle. Okay, so topic 1, Pascal's principle. Okay, so Pascal's principle says, for example, here we have a fluid filled in a container, okay, and there are two sides of this container. This side 1, okay, this side has a cross-section area of A1, okay, and the other side of the container has a cross-section area of A2, but A2 is larger than A1, okay, and this container is filled with the fluid, and on the smaller area side, on the side which has area A1, you apply a force F1, okay, you apply a force F1, and when you do this, you basically are exerting a pressure on this side, on the side where with the cross section A1, and the pressure you exert is the force you exert, that's the F1 divided by A1. The Pascal's principle states that there will be another force F2 exerted on the other side of this container, that F2. Okay, so this force will be applied here, and this force now will exert a pressure on this side of the container. So the pressure exerted by F2, by this force on A2, on the cross section A2, so we get the pressure here is F2 over A2. And the Pascal principle says that these two pressures are equal. Call this pressure 1 on this side, and call this pressure 2, which is being exerted on the side with a larger cross-section area. The Pascal's principle states that P1 equals P2, or simply we can call it P because they are equal. So in other words, F1 over A1 equals F2 over A2. So this equation is basically Pascal's law. Okay, so let's rewrite this slightly. F2 equals A2 over A1 times F1. Now this equation states that if you apply a force F1 this force on a smaller surface, the force F2 will be larger if A2 is larger than A1, because A2 over A1, if this A2 over A1 is bigger than 1, if A2 is bigger than 1, sorry, if A2 is bigger than A1, this A2 over A1 will be bigger than 1. For example, if A2 is twice as large as A1, then A2 over A1 will be 2, and then F2 will be 2 times F1. Okay, so it means even if you apply, for example, 10 Newton force, on the other hand side it will apply a 20 Newton force. Your force will get multiplied by a factor of 2. Okay, so this is how a hydraulic system works. For example, if you want to lift a car, okay, now to lift a car you need a large force. Okay, but if you have such a system where you apply a very small force on F1, and if the area A2 is much larger than area A1, then the force you apply will get multiplied, and you can basically lift this car with a much smaller force. Okay, so next, now I am gonna do an example. Now in this example here we are given that there's a force 1 you apply on this side. It has area A in means area A1, what I call it before A1 now is A in, and then a force on the other side of of this container is exerted on the car, that is F out. Okay, and we are given that R1 is 5 centimeter, so that's the radius of the smaller side, and R2 is 1.5 centimeter. So indirectly we are given the area A1 and A2. We are given radius, but these cross sections are circles or circular, so we know the cross section area. And we are given that to lift the car we need this much force. This is the weight of the car, so we need to apply at least this much force to the car. So this is F2. Okay, and we need to determine what is F1, how much force we need to apply so that F2 is this number. Okay, so now let's apply Pascal's principle. So F2 equals A2 over A1 times F1. Okay, in this case we are actually looking to solve for F1. Okay, F1 means the force on the smaller side, so F1 equals A1 over A2 times F2, and now we simply need to plug in the numbers. A1 is pi times R1 squared, that's the cross section area on the smaller side, over pi R2 squared. So this is the ratio of the areas multiplied by F2. Okay, and you see this pi cancels, and we are left with R1 squared over R2 squared times F2. R1 squared over R2 squared is simply R1 over R2 all squared. We can simplify in this expression, times F2. Now R1 is, so here generally we want to put radii in meters because these are given in centimeter, but because it's a ratio of R1 over R2, it doesn't matter which units I use, so we can leave this in centimeter. So R1 is 5 centimeter, because this centimeter are going to cancel anyways, over R2, which is 15 centimeter. This squared, oh sorry, this squared, yes, R1 over R2 squared, times F2, which is 13,300 newtons. Okay, so now we simply plug these numbers in and we get the force. Let me plug these into my calculator. I have not calculated these numbers before. So 15 square times 13,300. So we get the force we need to apply is 1447.8 newtons. Okay, so basically, yeah, let's leave it like that. Okay, so we need approximately 1448 newtons to lift this car, which weight is 13,300. So basically we need a much smaller force to lift this heavy car. Okay, so this number is much smaller. It's much smaller than the weight of the car. Okay, so in part B of this problem, we're asked what air pressure will produce a force of this magnitude. Okay, so basically it means when you apply this force of which we just calculated, what pressure will we be exerting on the fluid. So pressure in this case equals F1 over A1, and Pascal's principle state that this is also equal to F2 over A2. Okay, so we can use any number. We can either use F1, we know F1 and A1. We also know F2 and A2. So we can use any. So let's go with F2 and A2. So then pressure equals F2 over A2, and F2 is 13,300 newtons, and A2 is pi times R2 squared. Okay, so here we have to substitute R2 in terms of meters because the centimeter won't cancel, and okay, so this will be 13,300 newtons divided by pi times R2. R2 is 15 centimeters, so that is 0.150 meter squared. Okay, and we get the total pressure on each side by pi times 0.15 squared, and we get this number. So this is a huge number, 1.88 times 10 to power 1, 2, 3, 4, 5. It's Newton over meter squared, and Newton over meter squared is a joule. So Newton over meter squared, this thing is sorry, not joule, it's the Pascal, sorry. Okay, so this pressure is 1.88 times 10 to 5 Pascal. Okay, so atmospheric pressure is roughly 1 times 10 to 5 Pascal. So this is about 88% greater than the atmospheric pressure. Okay, so now this covers our first topic, and for the second topic, which is Archimedes principle, I'm going to record a separate video, and I'm going to upload these two videos. I may combine these two videos into one, or I may upload them separately. I have not decided yet. Okay, so hopefully this recording is useful for you, and if it works, I would be pretty happy to know this. Okay, see you in a moment.